Hello, welcome back. We are continuing to learn more about simple linear regression. And this video is going to show you another implementation of the LM function linear model functions in R. Linear model functions basically R's function to to fit linear models into data sets. And simple linear regression is also a linear model, and that's why we could actually use LM function in R to conduct a linear regression. So let's get back to our slides. And in this slide, we do see a different problem. In this problem, we do have a company called Bendrix, and we do have overhead cost, and we do have two different factors this time that can explain the overhead cost. So one is machine hours, another one is production runs. So let me show you the data. So the data here is in Bendrix spreadsheet. If you open it up, I'm not sure why it is taking this much time this time. Okay. All right. So here is our data set. So here we do have the dollar values here, the overhead cost, and we do have machine hours and production runs in each month, and we do have 36 months of data. And our objective is to see in this specific example, to see how much over the changes in the overhead cost can be explained by machine hours and then production runs. Let's close this and let's go to R. The R file that we're working on is simple linear regression.r file. Before I move forward, actually, I get these questions all the time. Why don't we do linear regression in Excel's data analysis toolpark, and we use R for it? The important answer here is the fact that Excel's data analysis toolpark can only handle data sets with not more than 16 independent variables. So if you exceed that number, if you have more than 16 independent variables, data analysis toolpark is not going to help you. And you will see that this is going to be 16 is just a very low number. In real life, it is actually a toy data set that people use much more than 16 when they build linear regression or multiple linear regression or any other prediction algorithm or data set or tool that they use. They definitely, I mean, usually have more than 16 independent variables. Even like an implementation with 8 to 10 independent variables can have multiple interaction effects. I'm going to explain what interaction means later, so in later videos. But if you try to also capture the interactions between independent variables, it becomes much more than 16 very quickly. And that's why we tend to use a different tool. People use Python, R, SAS, SPSS for that reason. But R is free and open source, and R is cool as far as you can tell, right? So far so good. I hope to hear that that word. Okay, so let's get back to our example. I just clicked on this sweeper object to clean out my memory here, and as you can see, you can still see my console from the previous video. And if you would like to also clean out the console, you could also. Oh, there was a sweeper button here, so it disappeared. I'm not sure where to find it. There should be also a sweeper like this one in a gray level here, but it's not here. But no, that's okay. I was just going to show you how to clear this portion in the console as well, but maybe it will appear back. All right, so let's focus on importing the Bendrix data set that I just showed you. And the way that we do it here is we come over here, it's an Excel file. We go browsy and then we locate it, and then yeah, it looks good. Okay, so it came here. I do have now my Bendix data set here. And what I do here is the first thing is to look at this, its structure, and then its describe function to check out some basic statistics to see everything is looking good. Yes, it does. All my numbers are numerical. That's fine. And let's first put together the simple linear regression model for explaining the overhead cost by only using the machine hours. And don't forget to add this data equals to Bendrix. So we are using the Bendrix data. And if you don't do this, R is going to give you error because there's no reason for R to understand what overhead is and what machine hours is unless it sees this data equals to Bendrix. It is understanding now that you are actually using the Bendrix data frame that you just exported. And I put the formula here. Remember, the tilde, left side of the tilde is keeping my dependent variable. This is the variable that I would like to explain. And the right side of this tilde is actually the independent variable. In this case, it is machine hours. And I labeled this as linear model 2. All right, so let's run this. And let's run the summary, the results of this linear model 2. So here is my results. Actually, my p-values look good. I do see that my p-value of the test is good. Now I can use this estimate for my intercept and my coefficient of my machine hours. Well, this basically tells me that my overhead is equal to the linear function here is this 48,621 plus 34.7 times my machine hours. So my overhead can be calculated by this function, all right? And how much variation does this explain in overhead? And this simple linear regression model can explain only 39.93% of the changes in the overhead, okay? This is how you can make sense out of these results quickly. Well, what about other models? So remember, my objective was to run machine hours and production runs. And then let's create another regression model. Let's call it this time LM3. And this time, I'm only going to change this machine hours to production runs and nothing else. All right, so let's run these two together. It did. Now it is giving me a different function for sure. So my p-values are looking good. Okay. P-value of the test is looking good as well. And this time my R square value is 27%, right? So it was 39%. So machine hours could explain 39% of the changes in the overhead cost, but production runs could by itself could only explain 27% of the changes in the overhead cost. And if you would like to use production runs to explain overhead, your formula is this, okay? Well, what about both of them? Can we use both production runs and machine hours to explain the changes in the overhead? Yes, we can, but it would not be a simple linear regression model. That would be multiple linear regression model, which is the subject of the next video.